Hello everyone, in this video I'm going to be solving this problem. It says the torus, which is kind of like a donut shape, is the solid obtained by rotating the circle, this equation, around the y-axis. Assume that A is larger than B and find the volume. What we're going to first do is graph this problem. So this equation, when it says negative A, it means that the circle moved to the right A units. And it also has a radius of B. Oh wait, no, this is not B. The radius is B. And which means that this length would be A plus B, while this length would be A minus B. But since we don't really need that, I'm just going to erase it. And this length from here to here, this length is about B because it has to be the same as the radius. And here is negative B. Oh no. And if I draw the circle, it'll kind of look like this. And we're going to rotate it around the y-axis. So I'm just going to kind of like mirror it and draw the exact same thing. This would be negative A. Okay, so now we're going to be rotating this around the y-axis. And just like the problem says, it'll kind of look like a donut, a torus, so kind of like this if we rotate it around the y-axis. And to find for the volume, when we rotate the solid, then we would have pi times the integral from, well, it's going to be dy in terms of y, so the interval would be from negative b to b, but I would prefer to multiply 2 and then just put the interval as from 0 to b. You don't have to do it this way. You can just set the interval from negative b to b and not multiply the 2. But this is just what I prefer. And inside the integral, we would have r squared minus r squared. And the capitalized R is the radius of the bigger circle. The bigger disk would be this. And the radius is this. And our smaller disk would be like this. My drawing is really messy, but I hope you can get the basic idea of what this looks like. Okay, so the reason we're going to subtract, okay, so this is called using washers. I guess it's because it looks like a washing machine. And we're going to subtract the volume of the bigger disk by the smaller disk. And the radius in the bigger disk is x. But notice that the radius of the smaller disk is also x. So like, does that mean that the two radius lengths are the same? Well, it's obviously not, right? This length is a lot longer than this one. But first, let's just use this equation to solve for x. Subtract y squared on both sides. Take the square root on both sides and we'll have x minus a is equal to plus or minus the square root of b squared minus y. Oh wait, no, e squared. There's supposed to be squared here. and add a on both sides so that you would have x is equal to a plus or minus the square root of b squared minus y squared. And also notice that we have two different values of x, right? So a plus the square root of b squared minus y squared will be the radius of the larger disk, and a minus the square root of b squared minus y squared will be the length of the smaller radius. It's pretty obvious why it's that, right? Because if we have the plus for the x, then the value will be bigger. I'll write x is equal to a plus or minus. Okay, actually, I'll just write it here. For the smaller radius, we have x is equal to a minus the square root of b squared minus y squared. For the larger radius, we have x is equal to a plus the square root of b squared minus y squared. Okay, I'm just going to erase this part now since we don't need it anymore. Now we can put everything inside our integral to find for the volume. The larger radius is equal to a plus the square root of b squared minus y squared, all of this squared. I'm so sorry. I'm just going to erase everything, this part, and rewrite it on the top. Okay, I'll fast forward it. Okay, so I just copied everything from here. After I erased the problem since we don't need it anymore, and we need more space. And subtracted by the smaller radius squared, and the smaller radius is a minus the square root of b squared minus y squared, and then all of it squared. We're going to simplify this part, which we would have a squared plus 2 times a times the square root of b squared minus y squared plus b squared minus y squared. And I just expanded it, and I'm going to do the same for this part. A squared minus 2 times a times the square root of b squared minus y squared plus b squared minus y squared. And as you can see, we can cancel some things out, like these two and also these two. So now that we simplified our integral, we can rewrite it as, we're just going to add these two, since we have negative in the front. 4a times the square root of b squared minus y squared dy. Okay, now from here, we really don't need the graph anymore, so I'm also going to erase the graph. Okay, now, since we're going to be integraling this in terms of y, we can just think of the 4 times a as constants, so that means that they can go in the front with the 2 pi. Okay, now to integral this, we're going to use trigonometric substitution. We're going to say y is equal to b times sine theta, which would mean that dy is equal to, we're just going to take the derivative of this, which you would get b times cosine theta d theta. And now we can just substitute b times cosine theta times d theta with the dy here, and also substitute dy with b times sine theta, and times the integral from it. Okay, and also since we're substituting, we will also get new intervals. We're going to, okay, so y is equal to b, so we're going to use this to find for our new interval. if we put b for y here, then we'll have b is equal to b times sine theta. Divide b on both sides and we just have sine theta is equal to 1, which means that theta is equal to pi divided by 2. And that would be, and we're going to replace that instead of having just b. And then to replace for the 0 in our interval, we're going to put the 0 for the y here again and solve for theta. 0 is equal to b times sine theta, which means that sine theta is equal to 0 if we divide b on both sides and solve for theta, and we have 0. So after we had we kept the 0 for our second interval. And then after substituting b times sine theta into the y, we have b squared minus b squared times sine squared theta. And I don't have space, so I'm going to make this smaller. Times dy, which is equal to b times cosine theta d theta. Okay, it looks like I'm going to have to erase this too. Oh, I'm erasing so much. I'm going to get a bigger board soon. And all we had left was d theta. Now, this is a trigonometric identity. B squared minus b squared times sine squared theta is of course equal to b squared times cosine theta. But we had the square root, so if we square root that, we would just have b times cosine theta. So we'll have 2 of these inside our integral. And if we multiply these 2 together, we would have b squared times cosine squared theta d theta. And of course, the b squared is a constant, so it can go in the front with the 8 pi times a. And you can just use the trigonometric identity 1/2 times cosine 2 theta plus 1, since these 2 are equal to each other, and then you can take the integral. But I know an easier way, and I would like to teach you guys that. So this is equal to 8 pi times a times b squared times the integral of cosine squared theta d theta from 0 to pi divided by 2, which means that we're just going to find the area of cosine squared theta from 0 to pi divided by 2. If we draw cosine squared theta, if you don't know this, it kind of looks like this. And everything is positive since we squared it. So there's no way we would have a negative value of y. So we're finding the area from 0 to 1, 0 to pi divided by 2, and that would be here. And I just basically memorized this. And let's think about the area of this rectangle. The area of this rectangle would be 1 times pi divided by 2. But we're finding for just this area, which looks about half of the rectangle, right? And it is half of it. So that means that it actually is half of it. So that means that the area inside here would be pi divided by 4. So you don't have to go through all that trouble substituting and then integraling it again. You can just draw it really quickly and you can figure it out easily. And finally we would have 8 pi times a times b squared times pi divided by 4 as our final answer. We got this as our answer for the volume when we rotated the circle. Bye.